Hello students, today we'll study force and pressure, this chapter. And in the lecture 1, first we have to know regarding the force. So what is force? Now whenever in your daily life you want to move any object, at that time you are using force. It may be you are using force, it may be against one object or it may be just at the side of the object, right? So here in this force, suppose you have one object here and if you want to move this in this side, so you have to apply the force from this side, right? So always we are using to lift some object or body, to lift some object we are using force, or to drop some object also we are using force. So this is the force, that means whatever you are applying to displace one object. So here, what is the force? A force is simply defined as a push or pull on a particular object. Okay. Now you have seen that you have the car door. Now you pushes the door or you pull the door whenever you want to use your car, right? So in this case, for this car also, you are using push a car door or pull a car door. Now, another thing, if some car that is not starting very well at that time, that means the self-start is not working properly, at that time you have seen in the road one picture is very common, that some people, they are just pushing the car to move the car, right? Until unless the car will not move, because the mass of that car is so high that it is not possible for one man to push the car. Okay, so here this, so the force, that means we are applying in the form of push or pull. Like whenever you are doing you are just kicking the ball, in case of football, at that time you are using one force, one type of force, or you want to stop any ball, at that time also you are using the force. Okay, so here push and pull. What is push and pull? Push and pull, that is also known as the force. Okay, an interaction of two objects that arises the force, and force has both magnitude and direction. That's why force is a vector quantity. So that's why force, I'm writing here, is a vector quantity. Vector quantity. Here you can see that one thing. Suppose I have one object here and it is just at the rest condition. It is just at the rest condition. Now I am applying the force. I am applying the force in this side. So it will move. It will move in this direction. So what is the direction of this force? From left to right, and this has some magnitude and this has some magnitude. So the force that has some magnitude as well as the direction, that's why the force is the vector quantity. The strength of the force that is expressed on the magnitude, and force brings about a change in the direction or state of motion. Now, what is a state of motion? Now, one thing you know that this object will be at rest condition until unless you are applying the force F, right? So that is the rest condition. And whenever you are applying the force F quantity, at that time you can see that it will move a little bit. So at that time it is in the motion condition. Okay. And after certain distance, it may be after traveling certain distance, it will again stop. So their state of motion, also the direction, that also dependent on the applied force. Suppose you have one ball here. Now what we can do with this ball, I can move this ball in this direction or in this direction or in straight direction. That depends on the applied force direction. So if I'm applying the force in this direction, obviously it will move in this direction. If I am applying the force in this direction, then it will move in this direction. So whatever the direction of the force, that decides in which direction the ball will move. The object will move, right? Here you can see two persons. One is the push, another is the pull. Another is trying to pull this door, and one person who is trying to push the door. So a push, that is a force exerted away from a body, from the body. Body means here object. Like hitting a snooker ball, kicking a football, these are the push. So what is a push? Push is a force exerted away from the body. Push is a force exerted away from the body. Okay. Next, there are several examples of the push and pull. First, we are trying to find out the example of push. Now, in our daily life, we can see a lot of example of the push. Now, after this lecture, you please try to collect all the examples that you are seeing from very morning to till night. Okay, like pushing the trolley. Whenever you are moving in any traveling, at that time you are using the trolley. So, and you are pushing the trolley here. And also you can see coolie. Whenever you are at the station of any railway station, you can see a person, that is coolie, who is just taking our luggage and who is carrying our luggage and moving the luggages. They are also using the trolley. Pushing the car when it breaks down. That I have told you. Suppose self-start is not working very well, at that time, some pushing of the car also you can see in the road. Pushing the table from one place to another, that we are doing a lot in our daily life, or it may be once in a week, to just move all the objects or orientation change of our objects in our living room or drawing room or study room, right? So these are the several examples of the push. And beyond that also I can say that if I want to open one door, at that time it may be push also you can use here, or whenever you are just trying to move one table, you are trying to move any object, at that time the push also you are using. Now the examples of the pull. Now curtain, all of you have curtain in your home, right? Now this curtain, whenever you are just trying to move this curtain, at that time you are pulling the curtain. You are pulling the curtain and dragging the box, opening the door, all these things you can use the pull. Now there is one thing, the door, whenever I can pull the door, I can push the door, that depends on the fixation of the door. Okay, so the pull, that is defined as the force, that is responsible for an object to move from the state of rest but in opposite direction when compared to push. Suppose for the push, the object is moving in this direction. For the pull, this object will move in this direction. Like if I go here, you can see that for push, this object is moving in this direction. But for pull, the object is moving in this direction, right? So here you can see that the push or pull, at that time different direction may be there. Now the force push and pull, here already we have explained what is push and what is pull. Here you can see very sweetie, and there is another boy, very cute boy here, who is trying to pull, and she is trying to push this thing. Actually they are helping each other, right? So a force that changes the direction of an object towards you, that would be a pull. That means the door is coming towards me. If I am just trying to open the door is coming towards me. So that is the pull. If the door is not coming towards me and it is going outward, at that time I am to apply the push. Okay, so here the force This point is very important. The object towards you and it moves away. That is the push and this is the pull. Okay. And force is simply defined as the push or pull of upon an object resulting from the object's interactions with another object. Okay. Push and pull, always there will be some interaction here. Now, any kind of force that is basically push and pull, that we understood very well. Now, what will happen for spring or elastic? Now, we have played a lot with spring and elastic, and you can see that whenever I am just pushing, just a minute, I am changing the pointer. Okay, so this is that spring here. Fine. Now, whenever I push this one, you can see that the spring will be like this much. Okay, it will shrink. But whenever I will pull this one, I can see that the spring will be like this. Now, elastic, you can take any girder. So here you can see that, suppose these are the two fixation points, that is your hand. Now your left hand is here and right hand is here. And this is the elastic here. If you give the force, at that time you can see that this elastic will at that time you can see that the elastic will extend. Otherwise, you can see that whenever you just remove all the forces, the elastic will be in its original position. So here, so many examples I have given here. First, you can see one person, he is trying to push this car where this car is not working. This man, he is just applying the pull force to get all the objects, heavy weights. Then this person is taking the hockey and he is trying to push one hockey ball here, and this is the boy who is just kicking the football, and that means push the ball. This person, there is a rope here. So these three boys, they are trying to pull the rope, and here the horse is trying to pull the car. So there are different examples of the push and pull in our society, in our daily life we can see. Now, there are different types of the force, like friction force, gravity. As you know that something, if you just throw at that time, after certain time, that thing will come to that object or that body will come to the ground. So that is due to gravity. And friction force, always you know that whenever you are working, at that time, some friction is acting in between you and your feet and the path. Then magnetic force also, you know, applied force, that push or pull, beyond force, tension force, drag force, spring force. So there are different types of force, but the basic types of the forces we'll discuss in the next lecture. Now, forces are due to interaction, right? An interaction of one object on another object that results in a force between the two objects, right? So that means some interaction should be there. So here, if a man stands behind a car, the car will not move. Obviously, the car will not move. The person, he will stand and at its condition, and the car also, it will not move. But if he touches the car here and push this car, at that time you can see that the car may move a little bit. So that means some interaction is, this interaction he is doing with the help of his hand. So this interaction is very important. Now different questions from this. What is force? Is force is a scalar or vector quantity? Already I have described that force has the magnitude as well as the direction. Now you can say it is a scalar or vector quantity. What are the types of the force? That already in a picture I have shown. What are the types of contact forces? That contact forces, different types of contact forces are there. What type contact force means? You have some interaction between the object and yourself. What type of force is the gravitational force? That also can be explained. Now the net force. Net force means whenever I am applying some force on the object. Suppose you have seen in your school days that in your school also some bench is there and one person he is pulling the bench. One person he is pulling the bench. One person he is that he is just applying the pull force. Another person is applying the push force. That means you are talking that no, don't move that table, right? So at that time, what you are doing? Suppose A person is here, he is applying push force, and B person is here, he is also applying push force, right? Because B does not want to change the position of the table, right? This happens in your school. So that thing here also, another thing can happen, that if you have here some table, at that time you can see that your friend is very good, he is pushing, and similarly you are also pushing this table to move this table in this direction, right? So here at that time you can see that both of your activity will be sum up. So when we apply the force in same direction, it adds to one another. This is the example. A plus B, whatever the force of A, suppose FA, and whatever the force for B, suppose FB. So here FA plus FB. Okay. So here when we apply force in the same direction, it adds to one another. For instance, if A pushing the table in one direction, B decides to help A move the table, applies the force in the same direction, then the force adds to the A. Okay. So this is the example. Now, net force, another thing that I have told you, suppose there is a table here, and A, he pushes the table in one direction by applying the force FA, and B starts to push the table in opposite direction. B, he does not want to change the position of the table, right? So he is applying FB. Now, if FA that equals to FB at that time, there will be no change in position. There will be no change in position. If FA greater than FB, at that time you can see that the table will move in which direction? If FA is greater than FB, the table will move towards right direction. Okay. Now, if FA that is less than FB, at that time, FB at that time you can see that, just a minute. At that time you can see that I have to remove this one. So at that time you can see that FA is less than FB, then the table that will move towards towards left direction. Okay, towards left direction. That right? So that means if FA is greater than FB, then A will win. If FB is greater than FA or FA is less than FB, B will win. Right? So this is the net force. So the net force in this case, that equals to actually FA minus of FB. That equals to actually FA minus of FB. Now the vector. Vector quantities that expressed in magnitude as well as the direction. Like I have told you, force is a vector and you are applying the force in this direction. It has some magnitude, also it has some direction. That means you are just trying to say one thing. I'm applying the force from right to left or towards right to left or left to right. That thing you have to mention. So force is a vector quantity, right? Now the net force I have explained here with the help of example. Suppose this is one block here and I am applying 5 Newton and 5 Newton in this direction, and another force has been applied, that is the 7 Newton. So what is the total of this much? That is 10 Newton. What is the force you are applying here? That is 7 Newton. That means here F1 plus F2, this much is greater than F3. So that means the block will move in this direction. And what will be the net force? For the first case, that net force equals to 10 minus 7, that is the 3 Newton. Okay? Because these two forces you are acting in one direction and this force you are applying in another direction. So net force is 3 Newton and it will be acting in this direction. Like I have told you, 10 Newton is greater than 7 Newton. So the block will move in this direction. Now here also there is a block here and we are applying F1 and F2. As I have told you, if both the forces are acting in same direction, then the net force will be F1 plus F2. F1 plus F2. Now, if two forces you are acting in opposite direction, F1 from left to right and F2 from right to left. So at that time, F2 minus F1, this is the net force. This is the net force. Okay. So always remember one thing, if I'm applying the force in same direction, how many forces are there? F1, F2, F3, F4, any forces. So at that time, you have to sum up all those forces. If you are applying the forces in different direction, at that time, the net force will be the subtraction of all the applied forces, right? Now, I think net force is very clear from all these slides. Now, effects of forms of forces. What are the effects of forces? I am applying force, fine. So what will be the effect? First thing is that, just a minute. First thing is that it will change the state of motion. It will change the state of motion, right? Suppose one body is at rest, then here one body is at rest. You are applying the force here. At that time, this body can move here and it will be placed here. If some object is at the motion, that means it is moving. At that time, if you want to stop that thing also, you have to apply the force. So that means you can keep your object in rest condition whenever it is moving also. So if you kick one stationary ball, or pick a book, you do so by use of the force. So change of state is there. If I'm lifting one book, that means I'm changing the position. So it is in the motion position now, right? Or I am changing the state of motion. Next, force can also change the direction of moving object. I have told you, if you are playing volleyball or if you are playing football also, at that time you can see that the direction of the ball, you can change. Suppose I have to throw it in this direction, so I have to apply the force here. And one thing is very important, whenever you have carom, you are just playing the carom, this is the carom board. At that time also you can see some yes, and the striker is here, the striker is here, and here also you have some portion to drop the, so you have to strike this, you have to strike this, and you have to detect which position is correct for you, which position is correct for you, so that this will move in this pocket, right? So in this case also, in case of carom also, you can see that the applying the force, I am changing the direction of the object, I am changing the direction of the object. So carom is a very good example of this this point. Now another thing I can do, that is the, suppose you have the football and now you want to make one goal. At that time you know whatever the direction, so that you can kick the ball and it will make some goal. So that means I am applying the force in towards that direction, right? Next, force can change the shape of the object. Obviously, all of you have played with the clay, very colorful clay. So you are making the clay some doll, you are making some doll, you are making some mango, you are making some mango here, some mango here, you are making some apple here, okay, in your childhood. So whatever you are doing with the clay, that means you are shaping the clay and you are making one object. So by using the force, so force can change the shape of an object. Force can change the shape of an object. So effects of the force, now just we are making the gist of this. Force can make the object to move from rest or rest from move, vice versa. Force can stop a moving object. Force can change the speed of an object if it is moving. Fine. Suppose the ball that is moving very slowly, you just kick with a very high force, you can see that the ball will move with a very acceleration. So force can change the direction of the motion of an object, right? In the carom also we are using this. In case of our goal also of the football, we are using this method. Force can change the shape of an object. Force may cause one or more of these effects, right? Thank you.